Approximately $55 billion has been invested globally to develop quantum computing technologies, and almost all of those technologies are based on the concept of a quantum bit, or qubit for short. So I'm going to give you an intuitive understanding of a qubit and how it's different from a regular or classical bit.
This little guy represents a qubit. Qubits are fundamentally really easy to understand intuitively. All they are is a point on the sphere that can have two things done to it. The first thing is that they can be rotated around the sphere. The operations that produce these rotations are called gates, and they form the building blocks of quantum circuits. Now, the second thing is what really makes it quantum. Qubits can be measured or observed in order to obtain a result. That's represented by this shaking motion. But, as you can see, for a qubit, measuring or observing the result actually changes the result. Measuring a qubit basically means specifying an axis and then asking the qubit if it's on the top or the bottom of that axis. So no matter where the point is on the sphere, at the end of a measurement, you're always going to be either on the top or the bottom of the axis that you measured along. And quick side note, this is what the qubit would look like in real life, in the sense that you don't see anything about the qubit until you measure it, and you can see which side of the axis it chose. You don't actually see what the qubit state is like in between, but for the purpose of this video, I'll be showing the state the whole time. If the qubit is already along the axis that you're measuring, it'll stay there. It won't move. And if the qubit isn't directly on the axis of measurement, it has a higher chance of going to whichever side it's closest to. But there's always the chance that it goes to the other side as well. And in a lot of scenarios, you'll see that it's equally far from the top and the bottom. This means that there's a 50-50 chance that it'll end up at the top or the bottom. And interestingly, if the qubit state is halfway between the top and the midpoint, you might think that there's a 75% chance it'll go to the top, but it's actually closer to 85%. And that is the consequence of some fundamental mathematical properties of quantum systems that we'll get into in a future video.
And that's pretty much it. The only two things you can really do to qubits are gates and measurements. Of course, it does get a lot more complicated when you talk about multi-qubit gates, gates that use multiple qubits, which can create multi-qubit states, which can't even be represented by just a light on a sphere anymore. But for a single qubit and just for the fundamental concepts, that is pretty much it.
And if you want to learn about more complicated topics like multi-qubit gates that can create entanglement, follow along and I'll be explaining more in future videos.